When it comes to aging, free radicals have long been portrayed as the root of all evil in our cellular world. And this dates back to the 1950s when the first theory was proposed. But just like every other theory that hits the scientific streets, they don't tend to be completely accurate, or in some cases, accurate at all. And deeming these ancient metabolic byproducts the root of all your cellular wrinkles happens to be one of these cases. In fact, they may even be good. Oh, what a tangled web we weave. Yo, what is up? Welcome back to another week of How to Health. My name is Kevin. I run liftandbalance.com, where we take aim at all things health and longevity and do it in an odd, weird, interesting, and highly sarcastic way. Today, we are taking a journey into one of the most misunderstood, most notably by mainstream health influencers, components of cellular aging, and talking about why free radicals are likely not the root cause of all things aging, although they may very well have a role. And just like all theories which become accepted facts in science, it's only a matter of time before we get more information that changes the story. Thus, why all scientific facts have half-lives. So, to tell this story, we will first explore how and why free radicals became mainstream, then talk about the problem with the free radical theory of aging, and finally suggest alternatives for their true role in the aging process, along with ways to mitigate your risk through lifestyle, and hopefully leaving you with a different perspective. A perspective that, if we're being honest, could be totally flipped on its head 5 years from now. I mean, who knows where ChatGPT will be at that point? Huh. That's funny. ChatGPT wrote this script. Why would they put that line in? Production team, unplug the internet. So let's embark first into what exactly all the hubba about these non-political radical figures are and how they affect our health. And to do so, we must begin back in the 1950s, where the free radical theory of aging was first described by Denham Harmon, proposing that organisms age because they accumulate oxidative damage. And this damage comes from reactive oxygen species, otherwise known as free radicals, which are partially reduced metabolites of molecular oxygen generated as byproducts of metabolic reactions, the most prominent being cellular respiration, or the synthesis of cellular energy from food and oxygen. Something we kinda need if we want to avoid our biological business closing for, well, ever. And for note, this respiration takes place in the energy-producing organelles which lie in numbers in every one of our cells, our mitochondria. And for many years, even to this day, this theory has been one of the most popular in the field of aging. But how did researchers actually come to this conclusion in the first place? Well, through the constant observation that reactive oxygen species and oxidative stress increase with age, and that reducing oxidative damage extends the lifespan in various model organisms, such as yeast, nematode, fruit flies, and mice. Huh, you don't say. So if that's the case, there should be a simple solution, right? Neutralize free radicals right when they hit the cellular streets. Bada bing, bada boom, fountain of youth, here we come. What's for lunch? What? We tried that already? What happened? Well, a molecule you may have heard of called an antioxidant happens to be one of the best ways to neutralize these radical actors, being able to donate an electron and stabilize the radical compound before it can drive surrounding damage. However, pretty much every human study which introduced a high dose of exogenous antioxidants, whether by injection or dietary means, has shown little impact to health span, aging, and overall longevity. In fact, in some cases, it actually worked in the opposite direction. Yikes is right. Ultimately finding that intracellular antioxidant levels are closely regulated by the cellular membrane, which has been observed to refuse entrance of these antioxidants to where the wild things live. The, free radicals. Indicating that maintaining certain levels of free radical activity are important and may even be good for cellular function. Gotta love biology. I mean, come on. So how exactly can this be the case? Well, researchers propose that reactive oxygen species may be providing key signaling functions, thereby activating protective and adaptive pathways that are necessary for cellular fitness. And in fact, this has been seen to be the case with some cellular processes, where free radical levels induce a change in genetic expression within the cell that alters its function in some way, shape, or form. The most extreme case of this being programmed cell death, or apoptosis, where free radicals play a vital role in signaling the cell to so elegantly destroy itself for the good of the organism. AKA me, you, that bird that just flew by, the fly on the wall, which may actually just be a Chat GPT spy. Production team, close the windows. That being said, it does seem that the levels of reactive oxygen species which ultimately accumulate within the cell are dependent on a combination of both environmental factors and the overall health of one's cellular machinery, as there's just a ton of variability in the role of oxidative damage in aging among different cell types, genotypes, metabolic states, and species across a vast array of different environmental conditions. Combine this with the fact that early researchers likely clung on to this free radical theory because it was one of the things the tools they had actually allowed them to measure. And we are just now developing the methods and technology to measure all the other complex unknown activity which happens within our cellular self. I'd say it's safe to expect more unexpected clues to pop up in this Scooby-Doo aging mystery. For these reasons, and many more, researchers are beginning to lean towards a theory of imperfectness, or the thought that cellular damage is generated as a result of increased imperfectness of processes, a portion of which potentially driven by oxidative damage. And ultimately, aging is the byproduct of accumulated biological damage, a crescendo of biological imperfectness, to the point of no repair over time. Damage which shifts the behaviors and functions of very specific cells throughout an organism, altering genetic expression, mitochondria function, enzyme activity, protein synthesis, and repair pathways. Something that natural selection, or the passage of beneficial traits between generations, can both slow down or accelerate depending on the circumstance, but cannot stop or postpone indefinitely. And this was interestingly observed in a 1998 Japanese study, which examined a variant in mitochondria DNA which modulated free radical leak, finding no difference in health or survival between people with and without the variant at age 50. However, by the time they were 80, the group with the variant was half as likely to visit the hospital for a medical issue and twice as likely to live to 100. Suggesting that the rate in which our ancient mitochondria leak free radicals may be one of the factors which signals cells to behave in a way which promotes the underlying dysfunction which ultimately leads to disease. Pretty interesting, no? But not without a fair amount of complex nuance.
Of course.
One of the reasons being that each cell type seems to be rather unique in its propensity to tolerate and resist this flurry of imperfectness as we age. Take neurons, for example, which are very precise in their energy requirements. And when they can't be met, they ultimately program cellular death. Yeah, not cool. And guess what? Although we have some evidence of adult neurogenesis, there's not just a pool of stem cells, as in the case of our intestinal lining, that are waiting to create a replacement neuron on demand. Don't work like that. When they die, they die. While on the other hand, neuron support cells called astrocytes have a much higher tolerance for imperfectness, almost to the point of despair, as these are often the origin of brain tumors, having much more resilience for survival in the face of internal cellular dysfunction. Dysfunction which over time sets the stage for mutations to take place and uncontrollable growth to ensue. It's a tangled web indeed. And recent data suggests that free radical leak rate from the mitochondria may be something to watch across all cell types, as researchers observed that cardiomyocytes, or heart cells, which can but do not turn over very often, showed a common increase in protein leak from the mitochondria in aged mice. And when the permeability or leak issue was fixed, they saw rejuvenated mitochondria function. Now, what does this actually tell us about reversing aging? Honestly, can't say at this point. But it's all nonetheless thought-provoking, providing another vantage point into the misunderstood world of free radicals, and how they may actually be necessary for optimal function, playing a signaling role which drastically alters the behaviors of a cell and allows it to adapt. However, this certainly seems to be one of those cases where the dose makes the poison, as we definitely don't want too many, but we also probably don't want too few, but a certain sweet spot which conveniently varies between cell types, allowing our biological machinery to do its thing for longer. Also knowing that there's just always going to be a trade-off, whether we know it or not. And all we can do is attempt, with the knowledge that we currently have, to put our pretty cool meat suit in the best position to operate efficiently. And that, my longevity friends, is something that we have at least a little bit of a say over. What type of say, you ask? This say is our lifestyle. This say is our daily habits and rituals. This say is what and when we eat, how much we move, how well we sleep, and the environment we place ourselves in. This say has the power to influence our ancient cellular machinery, which ultimately regulates the efficiency of our cellular self, and thus our odds, likelihood, and probability of health, vitality, and longevity over time. This is the say that you do, in fact, have control over. Yet, most intelligent walking apes on this beautiful floating rock never grab the reins and truly own it. They leave it to chance, accepting the false belief that their fate has been pre-written in their genes upon conception, a belief which modern science has proven to be far from the truth. For deep dives on all of this, we go in depth into fixing your mitochondria and optimizing your biological machinery in these two videos here, both of which will be linked below, discussing how exercise, real whole foods, fasting protocols, high quality sleep, nature, grounding, breath work, meditation, and stress management all have profound impacts in preserving the vitality of your younger cellular self. Because at the end of the day, your daily mood, feel, cognition, and physical function is simply a byproduct of your cellular efficiency. So take back control, bring the odds back ever in your favor, and reap the benefits of feeling effing awesome along the way. I mean, ChatGPT told me that age is just a number, and true biological age is on the inside. That being said, it also told me that Free Radical was a 90s pop rock band, but who's keeping score?